Today we are going to look at Leetcode word search problem. Given an m by n grid of characters, word, and a string word, return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. Here's an example we have here. The word is A, B, C, C, E, D, and because we have it in the board, we can find these or construct these words from letters of sequentially adjacent cells, where adjacent cells can be horizontally or vertically neighboring. We return true here, and here we see the word SEE, and here the word is ABCB. Even though we have ABC, there is no B adjacent to these cells, so we have to return false. And here are the constraints defined in the problem statement. So now I would like to talk about some approaches, some thought process, the possible approaches that I could think about. So the first one is going to be brute force. We can generate all paths. We can explore every possible path starting from each cell, checking if it forms the target word. This involves generating all sequences of adjacent cells, which is computationally expensive due to the exponential number of paths. So because the number of paths grow factorially here, it makes it impractical for larger grids. And the next approach could be that we could think about is backtracking with DFS. We can start from each cell, and we can use DFS to explore the paths that match the word character by character, mark cells as visited to avoid reuse, and backtrack to restore the board for other paths. Here the advantages are that it efficiently explores valid paths, pruning branches that don't match. It's suitable for grid traversal, and the disadvantage is that it requires careful handling of visited cells to avoid modifying the input board permanently. And the next approach that I could think about is BFS. We can use BFS to explore all neighbors level by level, checking if the word can be formed. But there's a big disadvantage here. BFS is less intuitive for this problem since we are matching a sequential string. And DFS naturally aligns with recursive path exploration. BFS would require tracking multiple paths simultaneously, complicating the implementation. And then the next approach that I could think about is dynamic programming. We can consider DP to memorize subproblems, but the problem doesn't have overlapping subproblems in a traditional sense. So DP is a overkill and doesn't fit the problem structure as well as backtracking. So I choose DFS with backtracking because the problem requires finding a single valid path that matches the word, and DFS is ideal for path finding in grids. And DFS naturally handles sequential character matching by exploring one direction at a time, backtracking when a path fails. It's memory efficient, and it uses call stacks, and it's memory efficient when compared to BFS, which requires a queue. the grid's adjacency, up, down, left, right, it makes a DFS a clean fit as we can explore neighbors recursively. So now let's talk about the optimization consideration. Before diving into DFS, I'd note that we can optimize by checking if the board has enough characters to form the word. Example, if the board has 3 A's but the board has only one, we can return false early. This frequency check reduces unnecessary DFS calls. And let's look into the code. So here we have the code and we have the exist method here, and this method basically checks if the word exists in the board, and if the board is null, we can see some edge cases here. If the board is null, empty, or has no columns, return false. And trying to make this, yeah, it's like, yeah, okay, I'm trying to make this one bigger. And then we have board dimensions. We store rows and columns for easy access. And then we have frequency check. It calls can form word, and to ensure the board has enough of each character to form the word. This is an optimization to avoid DFS if the word is impossible. And then we have the grid traversal. Here we iterate over each cell as a potential starting point. If DFS returns true from any cell, the word exists. If no starting point works, it returns false. And here we can talk about the method can form word. This basically checks, the purpose of this one is to ensure the board contains at least as many occurrences of each character as required by the word. So the frequency arrays, we have the frequency arrays here. We use a 52 element array to handle both upper cases A to Z indices 0 to 25, and lower cases A to Z indices 26 to 51 letters. And then we have board frequency. It iterates to the board, incrementing board frequencies for each character based on its case. And then we have word frequency. So iterate through the word and incrementing word frequency. If at any point word frequency of the character is greater than the board frequency of the character, the board lacks enough of that character, so we return false. And if all the characters in the word can be satisfied, then we return true. Now we have this DFS method. Let me give a quick explanation. And here we have these parameters: board, word, and row and call. It gives us the current cell coordinates, and index, the current position in the word being matched. Here we are checking the base case. If the index is equal to the word length, we have matched all the characters, so we return true. And then here the base case for failure, we return false if the cell is out of bounds, or or the current cell's character doesn't match the word at index. It's right there. And then When do we mock visited? We save the current cell's character in temp and mock the cell as visited by setting it to hash the special character, and this prevents reusing the cell in the current path. And then we have the directions. We define our 4 directions: right, down, left, and up, using a 2D array of coordinate offsets. And then we explore the neighbors for each direction. We compute the new coordinates, new row and new call, and recursively call DFS with index plus 1. If any direction leads to a successful path, we set found is equal to true and break. And we backtrack. We restore the cell's original character, which is in temp, to allow other paths to use it. And then we return found, indicating whether a valid path was found. Now we are going to walk through an example. So yeah, here's the input and the word, and now I'm gonna go line by line. So first we are going into the method exist, and here the board has the 3 rows and 4 columns, and now we are checking now we are calling can form word with the parameters board and word. And so now let's go and look into this method. And here we are creating board frequency, which is an array of size 52. It is initialized to all zeros because it is an integer int array. And so I'm going to say just like 0 0 0. It's going to be 52 zeros there, totally 52 elements there, so 52 zeros. And it's the indices 0 to 25 for the uppercase. Let me write it here. So the indices 0 to 25, therefore the uppercase A to Z, and indices 26 to 51, therefore this lowercase A to Z. So this is basically the array to store both character frequencies, and then we have word frequencies. It's the same thing here. It's a array of size 52 initialized to all zeros, and okay, this is to store the word character frequencies. So now we are inside the for loop. The row is equal to 0, and so board's length row should be less than 3, and so it's 0 is less than 3, and then here call, you're starting with 0, and call should be less than the column's length, which is 4, and so board of 0 0, what's that value? It's right there, it's A. And let me just check if input is same as the A, B, C, E, yes, F, C, yes, A, D, E, E, yes, that's right. Okay, so board of 0 0 is A, and so C is equal to A, and then if C is greater than or equal to A and C is less than or equal to Z, yes, the character is A, and A is obviously within the range of A to Z, uppercase A to Z. So we are going to say true and true. So it's true. So we are incrementing the board frequency here, and so it says board frequency of this C minus A, so that would be the C is A minus A is like 0, 65 minus 65, which would be 0. So we are saying board frequency of 0 is equal to 1. As first it was initialized to 0, now it's 1, and so that means it increments the frequency of A by 1, and then if the loop continues again, now we have row is equal to 0 and call is equal to 1. So what's the value there? 0 and 1, B. It's B. So there C is equal to B. And now what happens? So the board frequency, so yeah, we have C is like board of 0 and 1, which is B, and then what happens to the board frequency now? It's going to be the character is B minus A. So that's going to be one. And that's going to be um, board frequency of 1 becomes 1. Initially it was initialized to 0, so now it became 1, and then the loop continues. Now we have 0 and 2. Row is going to be 0 and column is going to be 2. And what do we have there? 0, C. We have C. So here what we have is we have C minus A. That's going to be 2. So now we have board frequency of 2 is 1. And then we are going to go here and we are going to say row is going to be 0 and call is going to be 3, and then what happens there? 0 and 3, 0, 1, 2 and 3. We have E there. So what are we going to say here? So I'm just going to copy here this one and E. So what's going to be E? So if it was D, it's going to be 3. So if it's going to be E, so it's going to be 4. So 4 and 4 becomes 1. And then we exhaust, and then we are going to the outer loop now. Now the row is going to be 1, and now it's going to be 1, 0, and what is that? So that's going to be 1. Yes. So here it's going to be S minus A, and let me just write it here. So I'm just going to write it this one here. So it's going to be or I'm just going to write it here. So for A it is 1, and for B it's 2, and for C it's going to be 3, and for D it's going to be 4, and E it's going to be 5. No, for A it's going to be 0 because it's 65 minus 65, it's 0. And for B it's going to be 66 minus 65, it's 1. And this C it's 2, it's for D it's going to be 3, and E it's going to be 4, and F 5, G is going to be 6. Seven. So here, okay, so these are the values, and so where are we now? Yes, so now for s it's going to be s minus a. It's going to be it's going to be 18. That's right. So it's going to be 18, and 18 is going to be 1 now, and we are increasing the frequency to 1, and then next again we are now it's going to be the next cell, so that's going to be 1 1. The coordinates are going to be 1 1. So what do we have? We have f there, and so what's the value of f minus a? It's going to be 5. So we are incrementing the baud frequency of the fifth element in the baud frequency array, and that's going to be 1 now. And then now the next cell coordinates are going to be 1 2. And what is 1 2? It's C. It's going to be C. And what is C minus A? The value of C minus A is 2. Because, yeah, that's how it, sorry. because A is 65, B is 66, and C is 67. 67 minus 65, it's 2. And so we are incrementing the element board frequency of 2. That's going to be 1 now. And then what's the next cell coordinate? It's going to be 1 and 3. And what do we have at 1 and 3? It's S. And we are going to say, again, it's S minus A. We know the value of S minus A, which is going to be 18. Okay, got it. So 18, and when we already incremented the board frequency of 18, and it's 1. The element at the board frequency of 18 is 1, and so now it's 2. It's going to be 2 now. And then we're going to the outer loop. The row is going to be 2 now. So what do we have at 2, 0? What do we have at the cell 2, 0? We have A. So I'm just going to say C. The character is A at 2, 0. And we already know A minus A, which is 65 minus 65, it's going to be 0. And we already incremented as it's the values there is 1, so it's going to be 2 now. Yeah, and here too I can see that you already incremented C once, so even this one is 2. And then now we are at row 2, column 1, and the character there at 2, 1 is D. Okay. So what is D minus A? Is 3. And that's going to be 1. And then the next cell coordinates, it's going to be 2, 2. And what do we have at 2, 2? We have E. And looks like we have an E already. Yes. So I can see the values here itself. It's E, and it's 4. So it's going to be 2, and the next cell coordinates is going to be 2, 3, which is E again, and we are going to increment the fourth value, the value of board frequency of 4, and it's going to be 3. And then now the final, I'm just going to say the state of the board frequencies as of now. So I would say why is it 1? Okay, oh, okay, got it. Board frequency of 0 is equal to 1, and if 1 is 1, I just want to save the state here so that it will be easy for us to look it up. And 2 is 2, 3 is 1, and 4 is 3. And we have 5, which is 1. It's 18, it's 2, it's not 1. So now we are iterating over the characters of the word. So we are saying we are using for loop here. For every character in the word, we are converting the word into a string word into a character array. And if c is greater than or equal to a, and if it's less than or equal to z, that's if it's uppercase, then we are saying that again we are incrementing the word frequency just like how we did for the board frequency. So we know in our example the word is A, B, C, C, E, D. So the word characters would be, character array would be A, B, C, C, E, and D. So here so we are looping, and now we are finding if it's within the uppercase. If it's uppercase, yeah, A is uppercase, so we are incrementing the word frequency. So the word frequency of should I write it there or here? I think I'll just write it here. So word frequency of A minus A, that's gonna be 0 again, so it's gonna be 0, which is 1, and then so the next character is B. So word frequency of B minus A, which is 1, that's gonna be 1. And so what's the next character? It's C, it's gonna be 2. So that's gonna be 1, and then the next character is C again, and what frequency of 2? It's 2 now, and the next one, it's gonna be E, C D E, so it's gonna be 4, and that's gonna be 1, and then next we have D, which is 3. Okay, now here we are checking, like, oh, I forgot to do the checks there. So is word frequency of 0 is greater than the word frequency of 0? Let's see that. No, they both are equal, so we don't have to return false. And now we're checking for 1. Word frequency of 1 greater than the word frequency of 1. Okay, that is 1, and here this is 1, so no, we don't have to return false now. Now it's for 2. That is 2, So this one is 2 and this one is 1, so no. No, they both are equal actually because they both are 2. Yep. And then we have 4 and 3, that's all. So word frequency of 4 is 1 and word frequency of 4 is 3. So that's not greater than this one. And 3. So this is 1 here, and let's look at the word frequency of 3, which is 1. So they both are equal, so no. Okay. So now we are going to return true there, and so back to exist we are gonna, so it's not returning false. I mean this one, this method return true, so negation of true, if negation of true, the negation of true is false. So if false, only if it's true it returns false. So here it's like if it's false, so negation of true becomes false. So yeah, the word can possibly be formed. And now we proceed to DFS. So now here the row is going to be 0 first. We're going to start with row is equal to 0. Again, remind me, yeah, row is less than, row should be less than 3 and col should be less than 4. So here so the coordinates are 0, 0 and the DFS board, the parameters. So first we are calling the DFS with the coordinates, the cell coordinates 0 and 0. And the index value 0 and now we are going to jump into the DFS with these values in, and let's go to the DFS and check it out. Okay, that's the first we are coming with these values, and so index is 0 is equal to word's length. What's word's length? It's 6. Word's length is, yeah, it's 6. I can 1 2 3 4 5 6. So it's, now we are not returning true now, and here, yes, row is less than 0. No, I mean like row is 0, it's not less than 0, and row is not greater than or equal to board's length, and col is not greater than or equal to the column's length, and board of 0 0 is not equal to the word dot char at index is said so. So yeah, basically it is equal, as you can see here. Everyone, so today we are going to look at the Leetcode problem word search, and in a previous video we saw half of the code. Now I'm going to continue with the DFS method, because I think I could cover it in a more elaborate way. And yeah, so here if you, I mean, I think I would just read the question here, or just explain that we have this board which is of dimension m by n grid of characters, and we have a word, a string, and we return true if we could find the word in the grid, if the word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. As you can see, like for example, this one would be a neighbor of this, the not that not diagonally, this, okay, this or this or this. And the same letter cell may not be used more than once. Okay, for example, if the target word is A B C C E D, here A B C C E D, we have to find the word, this word within the board, and we cannot use the same letter twice. If there was only one C here, this we have to return false. So let's look at the code now. So previously we saw the exist method and the can form word method, how it can find the frequencies of the characters in the board, and check it with the frequencies of the characters in the word, and it returns false if the word frequency, if the of a particular character is greater than the frequency that's present in the board. And also we are using 56. Something to note here is we are using 52 52 element array, and they all are initialized to 0. And yeah, so here we already saw this method previously, so now let's move forward with the DFS. So here we are calling the DFS initially with 0 0 and 0. So what happens when we call the DFS? Also we are going to talk about the DFS stack here, and basically I want to give a quick introduction to DFS stack. DFS stack basically refers to the call stack, and it's maintained by the runtime during recursive calls to the DFS method. So each call to the DFS method represents a state in the search. For here in this one, we have row and call. These are the current cell coordinates on the board, and index. This is the current position in the word being matched. So when DFS is called recursively, a new frame is pushed onto the call stack containing the parameters and local variables, that is temp and found, other local variables found in the DFS method. And here, yeah, we have found, and we have like temp. So for that particular call, so the stack grows as we explore deeper into the path, from 0 0 to 0 1 to 0 2, and the stack shrinks during backtracking when recursive calls returns either true for success or false for failure, and the board is restored. So here the tuple represents a stack frame for a DFS call. For example, this one. We only take this row call and index these parameters. For the first one, it's 0, 0, and 0. So I think I'm gonna write the stack here, and then or maybe I think I am going to, yeah, I'm going to use a Canva. For the stack. It's okay. I think I'm just going to use another slide maybe. Okay, I think I don't want to use Canva. I'll just use it right there. Okay, so now you could ask, like, why do we need to track the stack? The stack help us visualize the recursion depth and the path being explored. It shows which cell are currently active and that need to be restored during backtracking, and when a call returns that is true for success, the stack pops that frame and the board is restored for that cell. So let's look at the code now for DFS method. So the first call is, this is the first call, and let's go here to the DFS method. Here the DFS stack is going to be 0, 0, 0 row call, and for the row call and index, and now we are checking if the index is word's length. No, word's length is 6 here, as we can see. Okay, yeah, as we can see, the word's length is 6, and so we are not returning true here, and we are checking if the row is less than 0, call is less than 0, and row is greater than or equal to board's length, call is greater than or equal to column's length. They all are false, and so I'm just going to write the word here, just comment the word here just in case, so that I don't have to go up all the time. To look at it, so here, just gonna write the word here, and so this one here, it is equal to the board's first 0, 0, the first one, that's A, and also as we can, so we have to go there to look at the board. Board is this one, and the word, okay, I'm just going to copy the board too. So board of 0 0 is equal to, actually it's equal to the caret 0, which is a. They both are a, so they all return false. So false, 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 and false returns false. So here now we are going here in DFS stack. In state there's no change, and DFS stack is still this one, and then now we need to, so the now the temp becomes a, and because board of 0 0 is a, and then we are going to mark it as visited, and now we are going into the next one is directions. So here we can use this to move right, down, left, and up. So now we are initializing founders files, and we are going to go into this loop. We are looping through all the 4 directions, and so the first value is going to be, the first direction is going to be 0, 1, and so the new row is going to be 0 plus 0 is 0, and the new call is 0 plus 1, it's 1. And then here the DFS, we are calling the DFS with its parameters board and word, and so now it's gonna be 0, 1, 1, indexes, index plus 1, right? Yeah, so this is gonna be the new call, and just gonna paste it right here, and then so we are going to push this, this is going to be the second stack now, so I'm just going to copy, no, I think I'll just copy like only this. I think I will just copy these things and paste it here, and then, and it's just understood that it's board and words are already there, so I don't want to type it again and again, and then the next thing we have is, so now we are the words length, the index is 1 and words length is 6, so it's gonna It's not going to return true, and here all these conditions are false. And here, like as we can see, like both row and column, it's actually equal. I think they both are B. Yeah, the second value here is B, here 0 1 is B, and index here the word of 1 is B, so it's true. So it's not going to return false, and so because all these conditions are false. And now we are here, so here what's going to happen is temp, we are going to say temp is equal to B and mark it as visited. Now we are going to the directions. Okay, I think I'll just write like DFS tag here, so that so as you know, the stack, it's like it places the values on the top, right? Pushes onto the top. So we are going to have like this. And pops the removes it from the top of the stack. So I'm just going to I'm writing the stack like how it is. And now we are in directions, and now the new row is going to be 0 plus 0, which is 0, and the new call is going to be 1 plus 1. Yeah, that's the call, right? 1 here, and we already have 1, and plus 1 it's 2. So we have we are calling the DFS with, and the index, it's going to be 2 plus, because 1 plus 1, 0 2 2. So let's take it there. I'm just going to explicitly write it here just in case. So it's going to be 0, and this is going to be 2. And here, so here we are, and index is not equal to word length, false, so it's not going to return true. And here yeah, all these values are false. As we can see here, board of 0 comma 2 is this one, C, and index word dot character of 2a 0 1 2. See, they both match, so it's gonna return, this last condition is gonna return false too. So we are not gonna get into the if loop, and then we are here. So what temp is gonna be C. C. And we are gonna mark this one as visited. Okay, and then yeah, that's the DFS stack there. And here we can see the recursion depth is with 3 active calls, each matching a character in the path so far, like A, B, and C. And then what else we have? Then now we are getting inside the directions loop again, and iterating. We're going to iterate over the directions, and now let's say what's the new row is going to be. It's going to be 2 plus 0. 2 plus what? Okay. So how did we call this? We call this with 0 comma 2 comma 2, right? Yeah. Oh, okay, got it. So it's going to be ouch. Yeah, I'm sorry, it's 0. So new row is 0 plus 0, it's 0. And new call, it's going to be 2 plus 1, that's going to be 3. So we are going to call the DFS. So here the new row is 0 and new call is 3. And now we have, so we are going to call the DFS with 0 and 3. The index is going to be 3 incremented by 1. And okay, let's go there now. So we are going to say we are going to take it up here, and I'm going to add it to the call stack, the DFS stack I meant. Here this one, no, we have to skip it because index is 3 and words length is 6. And here all these conditions, they're gonna So all these conditions, they all are going to return false, and let's check this one. So 0 comma 3, what is that value? 0 0 0 1 0 2 0 3, it is E, and here it is char at 3, which is 0 1 2 3, it's C. Okay, that's going to be true, but so this condition is going to return true because it's I'm going to write it here, right down here. False, logical, or false. So yeah, and this one is 1 2 3 and 4. This is going to be false, and but this one is going to be true because this one here it's E and here it's C. Yep. So what are we gonna, so if this is true, then we need to return false. Okay, so we are going to return false, and what happens when we return false? We are going to pop this one. Pop. Okay, I'm thinking, should I remove it? Okay, I'll just do it like this. Okay, and then what happens now? So what happens when we return false? Okay, nothing happens because only if it's true, it's returned true. Otherwise, we are back to the DFS. Only if it's true, we are going to break the cycle here. So as if it is false, we are just going to continue with the DFS now. So here we are going to say, and one more thing that I want to say is, like, if we return false, what are we going to do? We are going to skip these, and we are just going to continue the loop. So the loop is going to be the next direction. Okay, so we are going to go here 1 0. We are going to change the direction, and yeah, only if it's true we are going to break the loop, and if it's going to be false, it just continues with the loop. Right, yeah. So here, this is the next direction we have. Now what's the new row and call? New row, new call. So we could say something like this. So we were going in the right direction and it failed because the E returned false here. This condition returned false. So we are going to try the other direction, which is down. So we are right here now, and we are going to try down, and we pop this one off. So currently we are only here, and so we need to calculate the new row. The new row is going to be 0 and 1, which is 1, and the new call is going to be 2 and 0, which is 2. What? Yeah, new row is 0 and 1, and yeah, that's right, 1 and 2. And now what's the index? Index is gonna be, we're gonna call the DFS. Because this one popped up the stack, we gotta use these values, and it's gonna be 1, 2 and 3 again. Maybe I would say this one is like maybe something like, I can push this out of the stack here. And maybe I can say pop. And then so we are going to call DFS there, and here it goes me 1, 2, 3. That's a good. And again I'll say pop. And here what are we going to do? Check the conditions here. No index is still not equal to the word's length, and all these conditions are going to return false. We know that because it's well within the bounds. And what about this board of 1 and 3? What is board of 1 and 3? 1, 1, 1, 2, 1, 3. Board of 1 and 2 or 1 and 3? 1 and 3. It should be 1 and 3, right? No, 1 and 2. 1, 0, 1, 1, 1, 2. Yeah, that's right. 1, 2 is C. Yep. And what is char at 3? 0, 1, 2, 3. C. They both are C. Yep. So this one, it's going to, it's not going to get in there because it's all the conditions are false and false. So here we have, now we are assigning the temp is going to be C, and we are going to mark this visitor. And now directions, again we are here. So here okay, did I add it to the stack? Yeah, I forgot. Yep, I need to add this one to the stack. And now that we are at directions, and what's the direction is going to be. So now we gotta find the new call. And it's going to be 0 and 1. So right now we are going down, right? So yeah. Yep, right now we are going down. So it's going to be 1 and 1, it's 2. It's going to be 2 and 2. And the index is going to be 4. Okay, here actually we can try the other directions. So I mean, like, I just don't want to make it like really very time consuming, so I'm just trying, this one down. We could like try all the directions, like, because as the loop goes from the beginning, it can like 0 and 1, 1 and 0, it can go like that. And and now, so if this is the call, we are going to call this one, and this is a call stack, the DFS stack. It's going to go on top of the DFS stack here. Now let's say we are trying the left one, which is, no, I forgot to do the temp. So here, all obviously, I mean, all these conditions are going to return false. And here, let's say board of 2 comma 2, 2 0 2 1 2 2, it's E. So we are going to mark this as visited and assign temp is equal to E. Now now let's say we are going to try the left one, which is going to be, the new row is going to be 2, and the new call is going to be 1. So let's say we tried right, down, and now we are at left. So here, and everything returned false. We know that, right? Because it's not the character at the board, it's not going to match those the character at the index at the word. So they all are going to return false. So we are going to continue with the loop, and right now we are at left. And here, so this is our current DFS call 2 comma 1, and it's going to be 5. So let's add it to the top of the stack. And here, so 2 comma 1, what's there? It's D. Okay. And caret 5 is D. Yes. So it's a matching one. So they all are gonna false, return false. So we are gonna mark it as the temp as D, and we're gonna mark this one as visited. And what is gonna happen? Now index, okay, I did, yeah. So the next call, it's going to be so right now we are going in this direction, right? Yeah, left. We are going in the left direction, and that means we are going to start it here, like so 0 and 1. So let's say new row is 2 plus 0, it's gonna be 2, and new call is 1 plus 1, it's going to be 2. And the index, it's going to be 6 this time. So that should be something that's significant, because when we take this call here, there, this is going to return true. The index length is going to be the word's length. Yes. So now we need to backtrack. As the recursive calls return true. So what happens if it returns true? It's returned true. So we are going to say found true, and we're going to break out of the loop, and we're going to store the cell's original value. So what are we going to do now? So we're going to backtrack, unwinding the DFS stack. So this, So let's bring the stack here. And we don't have to bring it here. So as we unwind, we are going to add this value back there. So for here, as we are going to go from the top, pop, and it's going to be D, and here this is going to be popped. And so what's that? Number 4. E, this is going to be E. Yeah, that's right. And then there's going to be C. And that's going to be C. And this is going to be B. And this is going to be A. Okay, got it. Now the DFS stack popped, completely popped all the values, and it popped to the empty stack now. And then so now we are going to return true, and the output is going to be true here. And so what's going to happen here? So we are returning true. That would be the output.